let me try to put a little video together to help you today while I'm not here. The sub should provide you with the study guide. I made a copy of that, so she should be able to give you the study guide for Chapter 7, Section 3. It's on similar triangles, so this is a big lesson. I'm sorry I'm not here. This is the first day I've missed all year, and I miss you guys. Let me just talk a little bit about similar versus congruent to start with. So the symbols are pretty close to each other. The little equal sign on the bottom of congruent is not there with similar, and so there's more on the symbol for congruent than there is on similar, and there's also more things that have to happen on congruent. For it to be congruent, two polygons to be congruent, and then this works with all polygons, but today we're just talking about triangles because they're special. But for any polygon to be congruent, they have the same shape and the same size. The angles will be the same, all the sides will be the same. Of course, correspondence matters, so we have to match up the right ones that go with each other. On similar, it's just the same shape, which means that the angles will be congruent. The angles have to be the same. However, the sides are in proportion. Angles are congruent, sides in proportion. And that's why we worked on solving proportions here the first couple of days of Chapter 7. So now, this is what we're dealing with today. When we're dealing with the triangles, then we can prove them similar by angle, angle, side, 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 or side, angle, side. So I just want to jog your memory about triangles and congruence. We learned that we could prove them congruent by side, 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 angle, side, angle, angle, side, side, angle, and hypotenuse, leg in right triangles only. Right? So we've been here, we're going here today, and let's just see how it works. You ready? So I've already worked a couple of these problems. You can always refer back to the top of this. This is where the information, like the theorems that go with this section, are up there. Angle, angle, side, 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 angle, side. This describes what I just talked about. So here's what the problems look like, at least on this page. So I'm going to determine whether the triangles are similar, and if so, I'm going to write a similarity statement. You'll remember back to the similarity statement, or the congruent statements. Order mattered, so corresponding angles have to match up, and so be careful with the order here. And so let's go through, and then we're going to explain why. The explanation is, which one of these is the reason why I can say they're similar, or if it's not, then I can tell them why it's not. It's either going to be that angles aren't congruent, or it's going to be that sides aren't in proportion, because that's the only thing I'm checking. So here's the first one. I looked at this. I saw a single slash on A and D. I saw a double slash on B and E, and that told me that these two angles are congruent, and then these two angles are congruent. So I have two angles in both triangles that are congruent, and so the triangles are similar because they give me enough information. The angle similarity is one of them. Now the only hard part left is to decide how do I say that. And the way that I say that is because there's one here and one here, then I know that A and D match up. That's why when I write this in a stacked fashion, this stacking is a concept that I've shared with you before, and that I think you're pretty comfortable with. So when I'm happy for you to write it like this. Most times you'll see it written out here, but it's fine like this. It's easier to see where everything goes. There's a lot of information in here. So A goes with D, and obviously B goes with E, and then the one that's left, it's a triangle. So we could easily prove that angle is also congruent. We don't have to do that, because if we know two angles are the same as two angles in another triangle, then we could easily subtract from 180, and the difference would be the same for both triangles anyway. Hopefully you see they're guiding us to the angle, and then the hard part is just naming it, and that's what we did here. Okay, the second one, this is more difficult because there's only one angle given. It's easy to determine if angles are congruent if they just tell us they're congruent. And in this case, because of the box, I know the 90 is congruent, but the other part of similarity is proportionality. And so the way that I did this was I said, well, I'm looking at the 90, and then I'm looking across, and so I know that the side across from the 90 has to be paired up in the two triangles. Notice the way they turn these things around, and that's part of the challenge, and we'll have to practice that to learn how to, deal with the misorientation. So that they're trying to confuse you is what I'm trying to tell you. I've learned to turn this thing around so that obviously W and L go together. That's easy for us to tell, but then where would X go? In my mind, X goes over here to J, which is going to send the Y over there to K. And then I'm going to check this, but how did I know for sure? Well, the longest number given to me has to match up to the other longest number given. So JL and XW would match up, and that's what I did. I said JL and XW, and then I know that the other one, KL, the shorter of the two, KL has to match up in YW. So this one's obviously smaller, so I said the smaller to the larger is the same as the smaller to the larger. There's my proportion. Here's me just subbing in the values for this proportion. So I put the value for KL here, I put the value for YW here, and I just subbed in the values. And then to solve it, I just cross multiplied. I solved like any other proportion, and when I cross multiplied this direction, I got 480. When I cross multiply this way, I got 648. So unless these numbers are the same, then these triangles are not in proportion. So therefore they're not similar. No is the answer. They're not in proportion is the reason. All right, and then for number 3, all they gave us was parallel lines, and by now, I hope, that parallel lines are going to lead you to congruent angles. And so the congruent angles here are marked because, like, if this was a transversal, this would correspond to this, and if this was a transversal, this would correspond to this. And so after you make that, after you figure that part out, then you realize that this one and number 1 are just alike, that you have two angles in this smaller triangle, and then oftentimes they'll do this where they'll put one inside the other, but in the larger triangle there's two angles that have a corresponding congruent angle in the other smaller triangle. Therefore, by angle, these two are the same. Obviously T goes with T because it's the same, and then the single notch, R with S, and then U with L. Hopefully that will help you to get going right there. So get after it. See if you can solve the rest of the sheet.